Boys and girls, welcome. Boy, oh boy, oh boy. First time that you've seen this. Oh boy. So apologize for not being able to go on live with you guys or really do this with you before. It just took forever to kind of get this thing going. And here we are, right? So this is going to be a quick video in terms of your final exam review. So on eClass, you should have seen the final exam notes page or review notes that I like to do for the unit tests. And obviously you've done a nice job with working on at least, and then some of you turned in the study guide packet for this final. So on the board here is what you see that is going to be covered for the majority standpoint on the final exam. So there's three things that you need to keep open when you take this final exam on Thursday. Obviously, number one is you need to have the exam open. It's going to be on eClass. I'll send instructions out that day of what that's going to look like. Number two, you need to have a tab open for Desmos. You are able to use Desmos on the final exam. Please use it. It's going to be pretty useful in terms of answering questions, finding out if tables match graphs and graphs match equations, okay? And then you're gonna get a formula sheet. I will give that to you digitally as well. If you have those three things open, you can actually turn this video off right now because you really won't need a whole lot of help for the final exam, okay? But let me go over 10 real quick things with you so you know what you really should be studying for and keeping an eye out for on the final. Number one is rate of change, so slope. I've got here an interval, so we're really talking about average rate of change, right? So what's gonna happen is you're gonna be presented with an interval of x, and you're gonna have to tell me which one of those graphs has the greatest rate of change or the largest rate of change on that interval. So you might see graphs logarithmic, polynomial, quadratic, exponential, rational, radical, all those types of things, right? But if you put those equations into Desmos and you see it, you will actually be able to physically see what's going on there. Number two, characteristics. You need to be familiar with end behavior, min, max for quadratics. You might need to have an absolute minimum or an absolute maximum, depending on the situation of the function. Definitely intercepts, because x-intercepts, roots, solutions, zeros, you need to know that. And asymptotes are somewhat important, but that's really just for the rational functions that we're going to talk about, okay? Next, you need to be able to solve equations. Any kind of equation, right? Radical, rational, polynomial, quadratic, linear, exponential, all that type of stuff. Literal equations too. Number four, you need to be able to use operations. Now, I really shouldn't have solve here, I should have simplify. But when you are simplifying these things, right? I'm talking about like multiplication, division, addition, and subtraction properties. So you can simplify equations and you can simplify expressions. What I really mean is rationals. So if you're dividing, make sure you flip it and then cancel things out. Number five, you need to be able to transform graphs. So not super in-depth transformations, but like if I have a logarithmic function and I want to shift it down 3 units and then do an x-axis reflection, what would that look like on a graph? Or what would that look like in terms of an equation? If you have Desmos open, you should be able to do that really easily, okay? Number six, domain of a piecewise. So remember the piecewise functions are the ones that have pieces, right? So if you're able to kind of piece together the domain from one to the other, that will be what I'm looking for. What's the domain of that function? Now again, you're probably gonna have a graph for that, or if you don't, you're gonna have a couple of equations. Just plug them into Desmos and you'll be able to see from, where does it jump from what point to the other, okay? Number seven, you're gonna have to match graphs to equations and situations. So matching a graph to a situation is easy because one of them will be given to you, and all you have to do is go onto Desmos and plug in the equation, and you'll be able to see which one matches nicely. For this one specifically, I'm talking about polynomial functions. So you know that if it crosses the x-axis, it's gonna have a 0 there. If it hits it and turns around, it's gonna have multiplicity. So it's gonna have 2 of the same value there. So you're gonna have to have like, I don't know, x minus 3, x minus 3. And so that would be your 2 values, so you can piece together what the polynomial function will look like, okay? Number 8, solve geometric sequences. I think there's a problem there about geometric sequences. It's just, you have a formula sheet, so you'll be able to use that really easily in terms of the formula. Number 9, factor polynomials. That really can go in with solving. Just make sure you're able to factor them. Now, if you have an equation that's a polynomial, plug the polynomial into Desmos and then see how many times it crosses the x-axis. I mean, Desmos is a tool that was like a no-brainer for us. We wanted you to have that. So again, this is, I wouldn't say it's an easy exam, but it makes it a lot easier because you're allowed to use that. And number 10, literal equations. think the stuff you did for the Unit 9 project. Okay, so just moving variables around and solving for literal equations. There's probably more of that than you would think. There's at least 3 questions of literal equations, I think, on there. So there's going to be 29 questions total. You'll have 2.5 hours to do it. So be really careful and mindful of the time, right? So I can't open it up again. Once it's open and you dig into it, you have 2.5 hours, 150 minutes to complete this final. I cannot do anything anymore after that. So once you submit it, you will get your score. But you've got to say to yourself, I've got to finish this a little bit before 2.5 hours, so I have time to check it and I have time to make sure that I've kind of given Mr. Drems all of the time that's allotted to it, and I did my best on it, because I can't get a text message that says, hey, something happened and I had to leave the house for something and whatever. I can't touch it again. That's it, right? So just make sure that you finish it well within the 2.5 hour limit, so you have some time to look over it. Okay? I would hate for you to get a poor grade on this because you didn't set aside 2.5 hours for you can just sit down and do this test. Okay? All right, guys. You should do very well on this exam. We built it in the mind frame of we didn't want to make it too challenging because A, we weren't sure about graphing calculators. B, we haven't been in school for 2 months, right? So yeah. Okay, see you later. Hopefully you have a nice day. And I'll text you, I'll let you know on Thursday of the schematics and when it's open. It'll be open at 10 o'clock in the morning, but I'll send you a text anyway. All right, bye.